Hello and welcome to this video on Quicks. Before I start, let's quickly take a look at the interface and what Quicks is. So Quicks stand for Quite Universal Circuit Simulator. It's a circuit simulator similar to LT-Spice or EDS or any other Spice that you must have used before. But what's different between Quicks and LT-Spice or other Spice-based simulators is that Quicks is able to do S-parameter simulation as well as some other simulations such as harmonic balance, and obviously it supports the other simulations of like transient simulation, DC simulation, which you can check here. So it supports DC simulation, transient simulation, AC simulation, S-parameter and harmonic balance. So this is quite useful software, I would say, or the simulator, especially for RF circuit simulations, because we have S parameter harmonic balance, and we can even do like parameter sweep here. So my main aim is to use Quicks for RF circuits such as like filters or maybe mixers, power amplifiers, low noise amplifiers, and we will go one by one in this tutorial. So the first video is just about getting familiar with the UI. If you have used ADS before, Keysight ADS, you can see that some of the things are quite similar. For example, like this, the label or wire, ground, a few things are quite similar to it. Even the simulation panel, if I just select as parameter here, for example, and place it here, so you can see it's quite similar to the ADS interface. It looks quite similar to ADS. So yeah, that's it. This is just a brief introduction to the user interface. And so let's see how to create our first project, and how what is the project flow in this in Quicks. So first step is to create a new project, which you can go to projects tab from here and simply select new here, or if you have some old project, you can just open it and you will see all the projects here which are there. You can even go to file and click on new, but this is going to make a new schematic within the same project. Currently there's no project open, so it's just a schematic. It won't run, it will ask you to save in some project. So the hierarchy is like this. First you need to create a project. We will create a project here by clicking new, and it will ask you the project name. So let's just let me name it as maybe project 1, and we click on create, and then it says modified files. Because the schematic was already open here, it says that this file is has to be placed in our project 1 folder, which must be somewhere here. Yeah, this is project 1 underscore prj, which is here, and then you just click on save selected. Now it will ask me where to save, or we can click on don't save. That is also fine. Yeah, so here but I need to put this schematic into some project, so I'll select our project because we need a working library, which is my project 1 prj. Now this is open. Once our project is open, it switches to the content tab, which has certain things like schematics and octave vhdl. This supports digital simulations as well, so we have other options for like hardware description languages such as verilog vhdl, and we just select schematic. That's it. In this schematic I'll save it in this. So let's go and save as. So this is the schematic which is already in project 1, and I'll just project 1, I'll just name this as project 1 save. Okay, so now you see all the content of this project 1, and then content. So it can have different type of content. Maybe there's some data set, some data displays which will contain the results or result templates and other things. So schematics will be saved. All the schematics linked to this project named as project 1 will be saved in the schematics tab. Currently it's project1.sch is open, and I can have multiple schematics, each one linked to each other within the same project. Let's go ahead and check very quickly how to place components, and I won't be running any simulation, but just a brief overview of the S parameter simulation specifically, because we'll be using S parameter simulation extensively throughout the videos for simulating various RF circuits. So next step is to place components. This is our schematic working area, and next step is to place components. You can go to components tab, and we have a wide choice of components here, which is first is like lumped components, and we have multiple choice of lumped components here. The basic like RLC is there, and then we have a ground, we have some sub-circuit ports, so that if I create a circuit which is a sub-circuit of some other, or which can be linked to some other schematic, which is pretty similar to ADS if you have used ADS before. And then we have other standard things such as DC block, DC feed, we have bias T. You can see a lot of RF related things here like isolator, circulator, and phase shifters, and a lot of other things. And then quickly let's go to sources. In sources you will find various type of sources: AC, DC, dependent, independent. But here, since we will be dealing with S parameters mostly, and we know S parameter talks about the power, we don't measure voltage and current in this parameter. We measure the power, reflected power and incident power. So for that thing we will be using this power source. I'll just show it. So we'll always be using power source. If we don't use power source, if we just use some other like AC or DC source, and we try to set up S parameter simulation, it's going to, the software is going to give an error. So always remember, S parameter simulation you will need a power source. And here you can see that the impedance is already set to 50 ohms, but you can always change it. So yeah, so in sources we'll be mostly dealing with power source, and I don't think we need any other sources as of now. Maybe later on if we move to some advanced simulations. And then another important option here is the transmission lines menu, in which you can see there are different types of transmission line elements here. First is the basic transmission line, which is a standard transmission line. It's not a strip line, or CPW, nothing. It's just a normal transmission line, the basic model which we study as the first transmission line model in any microwave textbook. Because if I place this, you will understand here it just talks about the impedance of this line and the length of the line, which is like just the impedance and the length. So this is not like width or anything or substrate. You don't define anything here, because this is just a transmission line, not a microstrip line. And then you can see there are other things such as coupled transmission line. We have a twisted pair conductor, we have coaxial, and we have rectangular waveguide. We have substrate and microstrip, coupled microstrip, and other types of like radial stubs, and I think we even, yeah, we have coplanar lines as well. So these are all the different microstrip and microwave elements which you can put in the schematic for doing simulations. Another important option here is the nonlinear components. Nonlinear components is basically all the active devices such as diodes, transistors, and MOSFETs, which we will be using in case of designing LNA or PA, where we need transistor model. And we can just put this, and we can set the parameters if you have of the transistor to, like, if I select the MOSFET, you can put the channel length and width of the channel and other things. And the last one is I guess, yeah, the diagrams. So diagrams one is very important, because this, whenever you run a simulation, the results will be stored in the variable names, which we'll see later, and but nothing will be plotted. In order to visualize the results, you need to go to diagrams, and we have to select what type of diagram we want to see. For example, if it's just a return loss plot, or if it's like S21, S11, or other S parameters, if I want to check in the then I need to select the Cartesian. And here, as soon as I select and I place it on the window, it asks you what is the input. But currently there's no simulation, so there are no variables here. But once you put some Once you simulate some circuit, you will find some variable names here which you want to plot, and it will automatically select the x-axis as the frequency. So apart from that, we have the ability to plot polar plot charts, and even Smith chart if you want to look at, let's say, the input impedance, how it's varying, or you want to do some matching. We have admittance plot as well, and we even have a table. So if you just want to see values at some frequency, or if it's, let's say, some harmonic balance kind of a simulation where you want to check the power of harmonics and which harmonic is present, so we can just go to tabular and you can plot the table in this window. So that's it for this one. I showed the project flow, how to create a project, the hierarchy of the software, where to place the schematic, how to create a new project, and where are the components located and what things do we need. This was very basic, and we'll see in later projects that we need a lot of there are a lot of other things, like such as defining equations to convert some variable into dB, or maybe if you want to, let's say, in case of a power amplifier, if you want to plot the stability criteria or other things, then you need to define some equations on your own and put it in the template and run the simulation, so that the results are calculated by the software and you can just plot them here. So yeah, that's it for this video. Thank you.